3.7. When we standardize the values of a variable, the distribution of standardized values has mean 0 and standard deviation 1. Okay, let me just pause there. When it says standardized values, right, that's the same as saying the z-scores. Okay. All right, so suppose we measure two variables, x and y, on several subjects, and then we standardize both variables. Okay? So we convert all the x values into their z-scores, and then we convert all the y values into their z-scores. Okay. All right, then we compute the least squares regression line. Suppose the slope of the least squares regression line is negative 0.44. We may conclude that, okay, and the statements are either about the intercept or the correlation. All right, so because we've standardized things, that means the standard deviation of the x values is now 1, right? It says so right here. That's what happens when you standardize. And we can say that the standard deviation of the y values is now 1 as well. Okay. Negative 0.44 is the slope, and the letter we use to represent slope is b, so negative 0.44. Okay. All right. Let's peek at our formula sheet, and let's look at this formula here. So this is how you would calculate the slope by hand, but we want to use this formula because it relates the slope to the correlation and the standard deviations. Right. So I'm just going to copy it here. The slope is equal to the correlation times sy over sx. Okay. Well, we know 3 of those values. Let's plug them in. Okay. Negative 0.44 equals r times 1 over 1. Well, that just simplifies to negative 0.44 equals r. So in this situation, if we standardize things, right, then the slope and the correlation will just end up being the same value. Okay. So the correct answer choice here is